out again to all the sponsors of the conference. Thank you very much for being here. Like I said, we couldn't do this conference without you guys, so really appreciate it. So Gael Delbary is our next speaker from DDN.
Thank you. Just a few words about myself before starting the presentation. At DDN, I am a senior field CTO. Okay, but before DDN, I worked for CA, the French Atomic Agency, as a main HPC storage leader. So I worked on large data compute nodes, 20,000 of nodes, large storage, but still on storage side. Just one thing about the venue and so on. I am happy to be there. The location is amazing. Lugano is pretty nice with the Como Lake and so on. So it's time to jump to the presentation. I don't know if it is going to be as nice as the location, but we will try to get this. So we are going to talk about multitenancy. And before starting, we need to define together what is multitenancy. Okay? When we talk with people, sometimes people told us, okay, multitenancy, we can rely on ACL POSIX. Perhaps sometimes it's sufficient for users. Okay, so I'm calling this a very, very light multitenancy behavior. Okay, it's not the goal of a real multitenancy solution. So when we are talking about multitenancy, we are talking about data isolation and also network isolation. But sometimes we need both. Okay, so and the next step is we need a solution to manage this. What our main customers are needed from us. So they need a nice performant global file system, okay, parallel file system, and they want to split the file system into different pieces, isolated piece of data. So we need to ensure data isolation, and this piece of area we're calling tenant. So that's a common name in all multitenancy solutions. So basically, the big picture is this, where you have at the center of the piece, at the center of the picture, the exascalar system. You have the global file system at the middle, and on left and right, you have some tenants which are going to access some data. Okay, and for sure, the data from tenant A, tenant 1 in this case, is not going to be accessible to the tenant 2. Okay, so before jumping into some interesting details, at the end we have two main products. We have the legacy one, which is Exascalar, which is relying on Lustre. Okay, and we have our new flagship product, which is Infinia. So I don't know if you have seen on the booth, but you have a presentation about this new product. This new product was designed from zero, okay, from scratch, and for sure it is multitenancy compliant by design. Okay, it's not some feature we have added to the system, but it's by design multi-tenant compliant. During this talk, I'm going to focus on Exascalar system. So what I'm proposing to you is just to build together this kind of solution. So you have at the top the DDN Exascalar system, where you have management servers, data servers, and metadata servers. Okay, and at the bottom you have the client's tenant. So you have tenant A, where you have a subset of groups of nodes where we would like to access to the parallel file system, but to a piece of this parallel file system. Okay, and you have the same on the right side about tenant B. So what we don't want is extra communication between tenant A and tenant B, for sure. Okay, and we need some data isolation. So how can we achieve this? first, we need to rely on one feature in Lustre, which is called node map. But it was not designed at the beginning for multi-tenancy solution. It was designed for a nice thing is that if you have a shared file system and you have two compute centers, and unfortunately, each compute center has its own user account databases. So it means that at sometimes you can have a collision between UID from one system to another. So you can tell me what's the issue. The issue is if you have a global file system, you can have a collision about UID from one system to another. So node map was designed to avoid this, to mapping, to get a new ID, GID, project ID range from selected client nodes. Okay, so like this, you can tell to exascalar system, okay, this kind of node, I'm going to map the UID from one specific range, and for the other compute nodes, I am able to map to another UID or GID range. So like this, on your file system, you have the guarantee that you have no collision about UID and GID and PID. So the funny thing is that with the extension, we have so many features with node map. So you have a list here, but yes, we can have some tenant because tenant is just a subset of nodes. So it's easy to have the notion of tenant. You can squash the root user. Sometimes people doesn't want that if root is accessing the node, root has to not be able to access the data. Okay, that's the root squash feature. You can find it also in NFS. That's the same mechanism. Okay, you can manage the quota because for sure what you want to achieve is that each tenant has to be a kind of data limitation. Okay. And for sure, you need to isolate the data to achieve this. We call this file set feature. Okay. So just to show you that how does it work, it's a quick, nice demo about node map configuration. You have on the left the servers, the exascalar servers, and on the right the clients. Okay, node 1, node 2. There is an exception, as you can see on the top left. The first servers is also a client with all privilege. So it means that the first client is able to mount the exascalar file system and to access all the data. Okay, so on this demo, you will see that I have created two tenants, tenant A, tenant B. On the right side, you have the IPs of each node. Okay, and you are seeing that in a few seconds after the tenant was set up, I am going just to mount the file system on node 1 or node 2, and you will see that root will not be able to gain access to the data of tenant A or tenant B. So in this case, on this node map configuration, we did just one thing. Okay, just set a number of nodes. So it's one node per tenant in this case, but you can extend to many nodes for sure. So we have the node 1 in the tenant A and the node 2 in the tenant B. That's it. And we are just seeing that we have a nice access to the file system. So nothing pretty exciting you can tell me. Okay. So you see that about the file system, we have a multi-tenant directory, top level directory, and below this you have two home directories, one which is called tenant A and tenant B, okay, with each user tenant A and tenant B, a user on each client node. Okay, so the next thing is to switch to another interesting thing. No, it's not the right, sorry. I would like to share with you some deep detail, about how it is implemented. Okay, so this kind of configuration we have seen together has to be stored on exascalar data structure. Okay, so in Lustre we have many files to achieve this, many data structure file. And with that map, we are relying on AAM file, index access module file. In fact, I am pretty sure that you know, pretty sure that you don't know IAM file, but I am pretty sure that you know the use case of this file. Because when you are using Lustre, you are relying on one FID, the Lustre file identifier of Lustre. And in fact, the file identifier of Lustre, you have a mapping between the FID and the inode you have on the drives. And to achieve this, you have to rely on IAM file. So that's the major use case in Lustre about AAM file. So that's a kind of tree. As you can see, you can retrieve all the configuration we have set up. Okay, and that's the way how we store the configuration. The nice news is that this kind of configuration is stored on MGS nodes, and we have some capability by design to sync all this kind of information on all server nodes. So that's pretty useful because node map feature are relying on the way that every server has to see the same configuration. Nice. Next demo is we need to isolate the data. Okay, so we are relying on file set feature. I don't know if you remember, but on this demo, you are going to see so same configurations at the same cluster. Okay, but on this, I'm going just to add one file set per tenant, so one directory per tenant. Okay, just to get the data isolation from each client. Okay. So you see directly from the node 1 that we have not the visibility of the file system. So that's the file set feature. Okay. When I have tried to mount the file system, I have directly jumped into the file set feature. Okay. So one thing which is still interesting is that root is still not able to write data in the tenant. Okay. But if I'm switch to the user tenant A, for example, for sure, I have the nice POSIX write on it. I am able to write. Just one thing which is interesting is that the file set feature is relying on another log structure, Lustre log structure, which is log. Okay, the log feature is pretty interesting for large events you need to store in Lustre. So, for example, if you have a billion of events, that's this kind of structure we use to store the events. But there are kind of trade-off on this, is that the log is increasing over the time. So you need to get some internal operation to get the space back. So right now the demonstration was been done from pretty old version of Exascalar, and just I'm giving you the information. Right now we are all moved to AAM files, even if the file set mechanism. So about data utilization, file set feature, okay. But we are relying on project ID. Project ID, just we are able to just add a kind of identifier on each directory, each file. Like this, we are able to manage quota and so on. And just a kind of ext4 struct, you can see that it is in the kernel upstream documentation. We see that we have an attribute which is pretty useful, which is tell you for a specific inode which project ID is. Okay, so you have another space command if you want to set up a project ID, and like this, we are able to manage the quota, for example. So, we are talking about data isolation, but we have not talked about data isolation, and we are not talking about network isolation. To jump, so we want this row below the interdiction to navigate between each tenant. What you have to take care in how Lustre is working to identify a client on the network. So it's relying on something like NID. NID is relying on two parts, before the @ and after the @ The first thing is a kind of network identifier. So it's relying on storage network interface. For example, if you have Ethernet, you have an IP LOS, okay? But if you have some other interconnect, like big SI interface, something like this, that's just a number, okay? The next part of the NID is the network name. The network name is also relying on a storage interface type, like TCP, if you use TCP IP to communicate with Lustre, or for example, PTF or LND, if you use another interconnect. That's the same thing for slingshot and so on. So just a nice view on how Lustre is communicate. So you have some client, and just to show you that client is able to communicate with management servers, with OSS servers, with NDS servers. So it means that if you want to do network isolation, okay, we need to be able to segregate the network. So the sad behavior is to tell, okay, we need to have 10 file system like we have 10 tenants, but it's not the goal. We need the same shared file system. So what we are doing is that we are going to write all the need configuration on the target, I mean on OSTs and MDTs target. So how does it work? You have an internal view on what we have if we are managing a multi-tenant configuration in Exascaler. So you have to focus your mind on the failover nodes where you have all the combination on Lustre nodes, on needs you have. So you will see, in this case, all the needs you have on each tenant. Okay, that's pretty important to understand all the, not the needs, sorry, the network name you have. So I don't know if you remember on the demo, you have TCP1 for tenant A, you have TCP2 for tenant B. Okay, and you have TCP0 for all the communication for MDS and OSS servers, which is the communication with all privileges. Okay. But to achieve this, I would like just to show you how does it work on client side. So the nice thing is that you have understood that you have set up a kind of configuration on server side. Okay, nice. We know that the server is able to communicate with TCP2, TCP1, and TCP0, but we have our client which is able just to communicate on each network, on each LNet network. So that's an example from node 2, so tenant B. Just an example about the failover needs that the client is seeing. Okay, in this case, the client is seeing only the needs, the server needs, which are on TCP2. So we are not seeing on client side all the needs for sure of the other tenants. Okay, so it ensures that there will not be extra communication with other network, Lustre network. But that's for the POC right now, but in the real life, it's just impossible because you have your network isolation, which is in place. So you can't communicate from one tenant to another. That's the goal. Okay, but I am pretty sure that you have some more constraints to add. So we can talk about authentication, for example. We can talk about encryption. We can talk about privilege escalation, something like this. So Exascaler is compatible with this kind of, I have just written three of technology about card authentication, SSH key shared key, or SE Linux, which is pretty helpful, in case of escalation. What we can bring with Exascaler? Okay, Exascaler, in Exascaler you will find all the patches relating to the feature. We bring you the support, and the last point of my first slide is that we bring you an API just to set up the tenant configuration. Because you have seen that there is so many commands to set up. It's not hard, but it's not unified and so on. So Exascaler is able to give you an API just to manage this. Okay. So to conclude, I am pretty sure that you are convinced that in this small demonstration you will see that multitenancy is a working solution with Exascaler. The nice thing is that we can scale up to thousands of tenants. Okay, we have some customers with 150 tenants. Okay, you can combine the solution with network, with authentication, and so on, and you can manage this by an external API. So you can just see two external links about Sébastien Buisson, which is from DDN One Cloud 2. It is the guy which built all the non-map feature, all the multi-tenant feature, all the encrypted feature we have in DDN solution. And the last one is Andreas Digger, our main architect of DDN Exascaler. So I have finished. Have you got any questions?
Thank you.